Okay, so I did give you notes, but they're very short. So if you need it, just pause the video and put that on in your notebook. I guess this is page 16, right? Just pause the video and get those. It's just little clues that you can use in the different forms. But for this one, for intercept form, the reason we call it intercept form is that we see the intercepts. We also call those the zeros, right? We also call those the solutions. It's this right here. We can see that right away. How do we see that? Well, it's always a x minus p times x minus q. P and q are the intercepts. I'll show you. So right here, remember, if they have a minus and it's plus, this is x minus negative 3. So p equals negative 3. Q just equals positive 1 because it already has the minus. So we're good. What does that mean? My zeros are negative 3, 0, and positive 1, 0. All right? Just understand, you can always use the calculator. But we're going to use this to help us find the vertex. So negative 3, 0, and 1, 0. Okay? If we know this line of symmetry has to cut everything in half, and this is here and this is here, what's the line that goes right in between these? Right? It was in our notes. We can add P and Q together, divide by 2, and figure out this line. But I'm looking at it, and this is 2 boxes right here. So right here is the middle. So that's going to be my axis of symmetry. Right? That's my axis of symmetry. That is at x equals negative 1. How did they get that? You do negative 3 plus 1 divided by 2. Negative 3 plus 1 is negative 2. Negative 2 divided by 2 equals negative 1. Right? So that being said, that's how I got this. I also know that my vertex has to have that as my x value, because it's got to be on this line. Right? So that really helps me. This has got the same rules where positive A is up, negative A is down. So right here, this is positive, that's up. And we know if it's going up, that's a min. Right? Domain is all real. And now, again, I can use my calculator if I need to. But here's the deal. If I know my vertex is on this, I know x equals negative 1, and I have my equation here, I can plug this in and find my answer. So if I put a negative 1 here and a negative 1 here, what's negative 1 plus 3? All right, this would equal my 2 in front. Negative 1 plus 3 is 2. And negative 1 minus 1 is negative 2. So it's 2 times 2 is 4 times negative 2 is negative 8. So my y value is negative 8. Guys, if that confuses you, just delete that from your memory and use the calculator. We can always put this in there, graph it, use the calculator to give you what you need, give you the vertex. But if I understand what's going on, I can use this, plug it in, negative 1, negative 8. That's my vertex. That's it. I have my picture already. What is my range? It's going to start here and go up. So it's going to start at negative 8 and it's going to go up to infinity. Again, the x value of the vertex goes here, the y value goes here. Same thing on the next one. If I say that this is P and this is Q, so my zeros are 5, 0 and 1, 0. 1, 0, 2, 3, 4, 5, 0. What's the line that's right in between these? It's this one right here. That is x equals 3. All right, there's my dotted line. So there's my x equals 3. Oh, my vertex needs to be on there. So 3 is the x value. A is positive, so it's going up. And if it points up, again, the vertex will be the minimum point. If it's pointing up, the vertex is the bottom. Okay, but I have a 3 here. I can plug that in. 3 minus 5 times 3 minus 1 times 2. So that equals 2 times 3 minus 5 is negative 2. 3 minus 1 is 2. So it ended up being the same. 2 times 2 times 2 is 8, and we have a negative, so that's negative 8. Ended up being negative 8. That's weird, but whatever. So positive 3, negative 8. Here's the point. Here's my picture. Domain, always all real. And for the range, it's got to start at negative 8 and go up to infinity. So hopefully we could do 4 and 5 and then make sure all of your work is caught up and everything is done.